Now, this is all about the Java application and Java build tools. Now, what about if you're developing an application with JavaScript? JavaScript doesn't have such a special artifact type like Java does, so it can be made into a zip or tar file. So how do we build a JavaScript artifact file as a zip or tar file? And what is alternative to Gradle or Maven in JavaScript? These alternatives are NPM and Yarn. So you can use either. NPM is much more widely used and popular, but they're very similar tools. They both use the same package.json file to manage the dependencies. So just like Maven and Gradle have their own dependencies files, where you can list the dependency names and versions, package.json is used in JavaScript applications to manage the dependencies. And NPM and Yarn both use the same package.json file. Note that NPM and Yarn are package managers and not build tools like Gradle and Maven. They install dependencies, but they're not used to build the application or to transpile and then build the JavaScript artifacts. So when we build a JavaScript application artifact, either we do not compress it and compile it, transpile it in JavaScript case, or we use other tools to do that because NPM and Yarn do not have commands for that. So this is a Node.js project, as you see, and here I have npm available and I can execute npm commands. So for example, I can do npm install, and this will install all the dependencies that are defined in a package.json file. So npm install will download them and make available for my project. And package.json is equivalent to pom.xml or build.gradle in Java projects. And here we define the dependencies. Also, NPM and Yarn use their own dependency repository, like Maven repository, in order to find the modules, which are like libraries for JavaScript applications, and this is an NPM repository. So the same concept applies here. You need some functionality. You can look for a library, a JavaScript module that can do that, and you include that in your package.json dependencies list. Here you can see the npm repository. So for example, if you need some dependency for your application, you can search it here. For example, if I need a driver for my Node.js for MongoDB, I can look it up here. So it works pretty similar to the Maven repository, where you have a dedicated repository for all the JavaScript modules, and you can look it all up here. And also similar to Maven and Gradle, they also have the command line tools where you can execute commands like start the application, stop the application, execute tests locally, publish the artifact, and so on. So once we build that zip file or tar file, what will that artifact file include? It will mostly include the code itself, the application code, but not the dependencies. Note that there are additional modules for npm and Yarn that will add this functionality to include the dependencies in the artifact, but by default, they're not included. And this means that whenever you want to run that artifact, the JavaScript artifact on a server, you first have to install the dependencies yourself on the server, then unpack that zip or tar file and run the application like you would run it locally using npm run or node command. So you need to copy artifact itself and package.json to the server in order to run the application. So this will be two pieces or two files that you need on that server. So actually, when packaging your artifact, you can decide to include the package.json also in the artifact to have them both in one file instead of working with two separate files. In order to create an artifact file from our Node.js application, we can execute npm pack. Here you see a tar file was created. So basically npm packed all the files inside that tar file. As I mentioned, npm is not a build tool, so it doesn't do anything with the code itself. It just packs everything up in one tar or zip file. So we can also look at that tar file. If I extract it, see there is a package folder, and here I see the application got packaged Docker file, package.json, and README file. Of course, you can configure what gets packaged into that tar file, what not, and how the name of the package will be, and so on in npm itself. Also, you can run a JavaScript application locally using npm start command, like this. So as you see in the JavaScript world, using those package management tools and build tools and the whole process is much more flexible than in Java world, and it's not as structured and standardized. That's why in a lot of different projects where they have JavaScript application, especially front and back end JavaScript applications, people decide themselves how they want to create the artifacts, which tools they want to use, whether they package the dependencies and package.json and everything in one file, and so on. So it's much more unstandardized in this way. Now, this was an example for backend JavaScript code. So if you're developing with a Node.js application, for example. But what about the front-end JavaScript code? Like, let's say we're developing an application with React, and in the backend we can either have Java or Node.js, or maybe some other programming language even. Now, there are different ways to do this. You can package the front-end code and backend code separately, having separate artifacts for both, or you can have a common package for both. For example, if we have a React Node.js application, so JavaScript in front-end and backend both, then we can have separate package.json files for each part, for the React code and for Node.js code, or we can have a common package.json for both in one file, where we manage all the dependencies. As an example of front-end, back-end JavaScript applications, I have this project here that uses React in the front-end, which is this part of the code here, and it uses Node.js in the back-end. And here you see that each part is a separate folder in the same project, and each one has its own package.json file where the dependencies for front-end and back-end parts are managed. Again, as I mentioned, it is very flexible. You can use any combination. It's not very standardized or structured in a way, so you can decide based on your project which one makes sense for you. But important thing here is that unlike Node.js, the React.js code needs to be transpiled, because otherwise browser cannot understand it. Because mostly in front-end code in React, Vue.js, Angular, and so on, we use the latest JavaScript syntax, which many browsers cannot yet understand. So we need to transpile that to the standard JavaScript syntax. And also needs to be compressed, so it's not too large for the browser to download, because otherwise it will be slower for the users. So in order to make loading the application faster in the browser, we need to compress the front-end code, the JavaScript code, and the CSS code into smaller files so that it can load faster. And there are separate tools for doing all of that, which are the front-end JavaScript build tools. Some of the most known are Webpack, Grunt, and so on. So Webpack, for example, is the most used one with React. With Webpack, you can build the code, like similar to how Maven or Gradle will build Java code, for example, and these files will be minified. And for the build process, you can actually configure what needs to be done or what you want to be applied to the code. For example, which files you want minified, like CSS and JavaScript files. So Webpack will build the code, it will transpile the code, it will minify the code, it will remove all the empty spaces, it will make the code machine readable, it will compress the file and make it way smaller. So you see this is the difference between packaging Node.js application and a front-end JavaScript application like React.js. And here you see the dependencies must be downloaded because they're not locally available yet. So in order to install those dependencies in package.json, I have to change to the directory where package.json is in, so API. And now from here, I can do npm install. And here you see all the dependencies got downloaded, including the Webpack dependency. So this could be considered as an equivalent for Gradle and Maven for their build functionality. And it is one of the dependencies in a JavaScript application that npm package manager actually manages. So now, in order to execute that, we are gonna call npm run build. And this build command, so to say, will call Webpack under the hood because we define it here. Otherwise, npm build or run build won't do anything, but we're overwriting it to call Webpack. So if I execute this, you see Webpack is called, and it does bundling of JavaScript to reduce its size and some other stuff. And here you see server.bundle.js was created. And if I open this, this is actually a very compressed, uglified, so to say, file to make it smaller in size. As well as the code was also transpiled. And obviously this is a simplistic use case, so to say. With Webpack you can build both front-end and back-end, and you can do all sorts of things with different modules that you can configure for Webpack. So what about the dependencies for front-end code like React? It also has some dependencies just like Node.js. So the same way you can use npm or yarn to do the dependency management as well. And as I mentioned before, you can use common package.json to manage dependencies for both front-end and back-end in a Node.js React application, or you can have separate package.json files. But it's definitely an advantage and can be used as an advantage to have the same build tools and same package management tools across front-end and back-end throughout the whole application. But again, no standards or standard ways of doing that exist yet. And in case React.js has a Java backend, which also is a very common application setup, same concepts apply. So you build a front-end application with Webpack, you can manage its dependencies using npm or yarn. However, when it comes to packaging the whole application, usually you would package the whole thing in a WAR file where the front-end code and back-end code is all in one, which is of course pretty convenient. And there again, Java has more standardized way of doing this. So this is actually rather a best practice to do it this way.